binary analysis revolves around the examination and evaluation of binaries. To understand this field better, let's delve into the fundamental concepts of binary formats and life cycle of binaries. Once you grasp these concepts, you will be well prepared to tackle the subsequent sections, which we will delve into ELF and PE binaries in next sections. So these two formats are extensively utilized on Linux and Windows systems, making them crucial for comprehensive binary analysis. In the realm of modern computing, computations are carried out using the binary numerical systems, which represents numbers as sequences of ones and zeros. The binary code, also known as machine code, is the language executed by these computer systems. So a program comprises a combination of machine instructions, which as named binary code, and data such as variables and constants to manage the multitude of programs on a given system effectively. It becomes essential to store the code and data belonging to each program within a single file and self-contained file. So these files containing executable binary programs are referred as binary executable files or simply binaries. So the primary objective of this course of this section is to explore and analyze these binaries comprehensively for malware analysis and reverse engineering. So before we dive into the intricacies of binary formats like ELF and PE, let's begin with a broad overview of how executable binaries are generated from source code. Following that, we will dissect a sample binary, allowing you to gain a solid understanding of the code and data encapsulated within binary files. Armed with this knowledge, you will proceed to explore ELF and PE binaries in next sections. And also in next sections, you will have the opportunity to construct your own binary loader, enabling you to parse and analyze binaries. So firstly, we will understand this compilation phase. So the production of binaries involves a process called compilation, right? Which translates human-readable source code such as C or C++ into machine executable by processor. So here I draw some diagram, and this illustrates an overview of these steps typically involved in the compilation process for C code or C++ code. Similar steps apply to some languages as well, and compiling C code encompasses four phases here: the preprocessing, compilation, assembly, and linking. So interestingly, one of these phases is also known as compilation, and creating a peculiar overlap in terminology. Although modern compilers often merge some or all of these phases, we will examine them individually for the sake of clarity and demonstration. So firstly, we have the preprocessing, which you will also learn more deeply in next lectures. So this initial phase involves the preprocessing of the source code. It includes the operations such as macro expansions, file inclusion, and conditional compilation. So preprocessing ensures that the code is ready for subsequent stages of compilation. We also have the compilation. In this phase, the preprocessed source code is translated into assembly language specific to the target architecture. So the compiler analyzes the code syntax, checks for errors, and generates assembly instructions accordingly. In third, we have assembly. During assembly, the compiler further translates the assembly code into the object code, consisting of binary instructions and data representations specific to the target processor. This step involves resolving memory addresses and generating relocation information. And lastly, linking. Finally, the linking phase combines the generated object code with the necessary libraries and object files to create a fully functional binary executable. The linker resolves symbol references, performs memory address fixing, and generates the final binary file ready for execution. And it's important to note that although the four phases mentioned here are typically distinct, modern compilers often optimize and streamline the process by merging some or all of these steps. So nonetheless, understanding each phase individually provides a solid foundation for comprehending the intricacies of the binary analysis process. And by familiarizing yourself with the compilation process and the anatomy of binaries, you are now equipped to delve deeper into specific formats of ELF and PE binaries. So these widely used formats hold a wealth of information waiting to be explored and analyzed, offering valuable insights into the inner workings of executable programs. And here we have this diagram here. So now let's delve deeper into the processing phase in next lecture.